In this video, we're going to talk about how you would determine the net force on an object. So let's say you have this situation. You have an object that has a weight or a force of gravity of 20 newtons. It has a normal force of 20 newtons, so it must be resting on some surface. So maybe you have a box resting on a surface. And it has an applied force of 30 newtons and a force of friction of 10 newtons in the other direction. And you're asked to find the net force. Well, the net force is the overall force. So let's say you're looking for the net force on this object. You can't just take and add 20 plus 30 plus 20 plus 10 to get the net force, because the forces are vectors and they have direction. And so let's see this force right here. You have 30 going to the right and 10 going to the left. That friction is taking away from the applied force of 30 newtons, and it's going to subtract from it. And these two are also balancing each other out. So when you're looking at net force, just like when we were doing projectiles, you have to separate this into the X forces and the Y forces. And you can add and subtract vectors going in the same direction, so the Y forces, and you can add and subtract the forces in the X direction. But you can't just add up all the forces together. These are vectors. So this little symbol here is the Greek letter epsilon, and it just means the sum of. So net force is your total force, or the sum of your forces. So I could write it like this, or I could write F net. They mean the same thing. So I'm going to sum up the forces that I have in the X direction. So in the X direction, I have this 30 and this 10. The 30 is bigger, so we'll go ahead and call that one, and it's to the right, so we'll call that one positive, which means that this one to the left is negative. So 30 minus 10 is 20 newtons. So in the X direction, we have a force of 20 newtons. So the sum of our forces in the Y direction, or the net force in the Y direction, going up, we have normal force of 20 newtons, and going down, we have a weight force, the force of gravity, of 20 newtons. And so those two are balanced. So overall, we have, on this object, we have a net force of 20 newtons, which means it's going to be accelerating to the right because it has a net force of 20 newtons to the right. Now, how would this be different if instead of having balanced forces in the Y direction, we had unbalanced forces? Let's say we have an object that has this going on. So 50 newtons in this direction, 30 in that, 40 newtons and 10 newtons. Well, if we sum our forces again in the X direction, so we have 40 newtons to the right and then 10 newtons in the other direction, so we'll subtract that, which leaves us with a 30 newton force to the right. In the Y direction, we have a 50 newton force going up and a 30 newton force going down. And so that leaves us 20 newtons to the up. So we know that overall we have a net force to the right as well as a net force up. For these, we can't just add them together and get 50 newtons because they're vectors and they have direction. And if you think about this, if it's going to the right and it's going up, then really what you have is a force going this direction. If you visualize pushing on these, you really have a force that's doing this. Overall, your box is going to move this way. Well, we have a triangle. And if we're looking for the net force, what we're really looking for is the magnitude of this arrow, this vector, which is the hypotenuse of our triangle. And our vector has an x component of 30 newtons and a y component of 20 newtons. And so F, or our force, is going to be found using trigonometry. Whenever we're looking for that vector, square root of the x portion squared plus the y portion squared. So that's going to give us the square root of 30 squared plus 20 squared, which is 36.0555, which rounds to about 36. And this is a force, so it's newtons. So this overall force here is 36 newtons. We'd also need that angle. And so remember, for angle, we're going to use the inverse tan. And generally, it's just y over x, if you have it set up this way. And so the y portion was the 20 newtons. And the x portion was the 30 newtons. So the inverse tan of 20 over 30, and you get 33.7. Now remember that we're trying to describe this net force. So F net is a vector with a magnitude of 36 newtons going at an angle of 30, we'll call it 34 degrees. And we don't know if this is north, south, east, or west, up or down. We don't know, but we can say that it's above this horizontal. And that works, above the horizontal. So if you have an object that has a balanced force in one direction, but an unbalanced force in the other, it's easier to find the net force. It doesn't require trigonometry. But if you have an object that has unbalanced forces in both the x and y direction, then you do have to use trigonometry to find that unbalanced force. And then obviously we'll break these forces down into x and y components later using trigonometry as well.